All right, so yesterday we started talking about piecewise functions. Remember we said about piecewise functions. They are a little different than what you're used to. A piecewise function is one that has multiple equations in the same function. Depending on what x value you're at, that determines which function you're on, which part of the graph you're on. Yesterday we given some piecewise functions. We did two things. We learned how to evaluate piecewise functions. So if I want to plug an x value into a piecewise function, I have to be careful. So I have to be careful that I'm getting the right line in the piecewise function, the right piece, and that depends on the x values. The other thing we did is if we started off with a piecewise function, we graphed it. You might remember we created a breaking point, and we drew that vertical line, and then we just graphed the different lines, either to the left or the right of the breaking point. And so I think we got, you probably need some practice on that, and I understand that. But I think we got a pretty good start on that stuff. Now, today I want to do the opposite. Today, this is a little easier. Today I want to start with the graph of a piecewise function and have you work backwards and tell me what is that equation? What's the function if we give you the graph? Okay, so what about this one? Got this piecewise function. I know it's going to end up looking like this, right? I've got f of x equals, and then I'm going to have two parts to this one, right? I just need to know what are those two parts. Okay. Maybe the first thing to do is to decide where's the breaking point on this one. 0. Okay, so we've got a vertical line at 0. That's what splits this thing up, and we're going to have two parts to this. We're going to have the part for, what about this part over here? The right piece of this function. What's going to be the domain of that? For what x values does it live? When x is what? Greater than or equal to 0. Good. So if x is greater than or equal to 0, we're going to get this guy, right? The other one is going to live where? Less than 0. Okay, but not greater than, because we have that open circle, right? Okay. So we have to just find the equations of those two lines. Well, let's go ahead and start with the right one. How about? I want to put it into slope-intercept form eventually, and this one I actually can't I? Because I can see the slope and the y-intercept of this one. What's the slope of this line? I'm rising by 1 and running by 1. All right. What's the y-intercept? 0. So what's the equation of this line then? 1x. Yeah, 1x plus 0. In other words, and if I'm going to say 1x plus 0, I don't say the 1, do I, in front of the x? It's there, and I don't need to write the 0. So I just have the line y equals x, so f of x just equals x. Right? That's my y, isn't it? F of x is my y. Okay, make sense?
But can you write it, though?
Say it again.
Can you write it?
Well, okay, you could, but what we want to do when we write these functions down, we want to write them in the simplest way. And so, even though we know it's there, we prefer not to. We prefer not to write that 1 in front of the x because it just sort of complicates things. And the plus 0 doesn't add anything to it, right? And so we don't need that part either. Yes, ma'am. Well, I understand the question. Because here's an answer that may not be so good, but this is for my purposes. This is why I would say I don't want you doing it. I'm training you not to do it, because later on when you start getting into bigger algebra stuff, and algebra gets big. I mean, really big. I can remember doing a problem in college in a quantum mechanics class. I'm not kidding. It's like 50 pages of algebra just for this one problem. If you start adding extra marks, and it contaminates it. It just makes it more complicated. So it's really important. In fact, I'd say it's critically important as you go further in math to make it as efficient and trimmed down as you can. Otherwise, it just gets to be too much stuff, and it's easier to make mistakes. And so it really is. I know it sounds kind of, like, oh, big deal. It's just a little stylistic thing. But a mathematician would say, no, that's a big, big deal. We do not want to be writing those extraneous coefficients and terms. If they're not there, don't write them. Okay? And even though it's mathematically the same thing, like I could say, how many apples do you have? Well, if I have 6 apples, I could say, yeah, you have you have 8 minus 2 apples, but I don't want to say that. I want to say you have 6 apples, because that's easier, right? Yes.
In other words, multiplying by one, adding by zero.
It's, right, it doesn't, I mean, it's because 1 is the identity number for multiplication. That's the number that we know. When you multiply something by 1, the identity stays the same. 0 is the identity number for addition. When we add 0 to something, it stays the same. For that reason, those 2 special numbers we like not to include when we don't need to. Does that make sense? I mean, it may not be the most satisfactory answer, but partly I'm just going to say, just trust me on this one. It's something you want to do. Okay? All right, what about this guy over here?
Negative x.
Okay, so what's the slope?
Negative
1, okay. Because I'm still just rising by 1 and running by 1, but what's the y-intercept this time?
Negative.
2. Now, even though 2 doesn't sit on this line, if I were to extend this line forever, it does go through 2, right? That's going to define the shape of the line, right? The line, even though we're only graphing a portion of this thing, remember what we said yesterday, we're just going to put the ruler up here, and we're only going to graph the part of this infinite line to the left of the breaking point. But the equation of the line is just like it would be if it went forever. The equation of the line is just defining the shape of the line, right? This is the part right here that's telling us, only draw the part to the left of 0. But the equation is the same, x plus 2. With what the slope? No, the slope is positive, and I understand why you might think it's negative, but it's positive because if we look at the rise over the run, and here's a good rule of thumb, when you're doing slopes, you always want to start at a left point and move to the right. So we're going to pick a point, and then the ant's going to walk along this curve from left to right. So if we pick this point right here, his rise is going to be positive 1, because he's going up, and his run is positive 1. If it were negative, the line would be going down like that, right? Positive lines, positive slopes always mean the ant is walking uphill from left to right. They're increasing functions. Negative slopes mean the ant is walking downhill from left to right. We call it a decreasing function. Okay? Does that make sense? So the line had the equation y equals x plus 2. So x plus 2 is what we're setting our y equal to in the second piece. Okay? Let's look at one more I want to look at one where it doesn't break right at 0. And then I think we're good to go. Anyway, this is, I'll put this PowerPoint up so you can look at these steps if you want, but we pretty much went through that. Okay, so there's our piecewise function. Now, one thing on that looks a little different than we wrote it, doesn't it?
Yeah.
Is this a big deal? We had the x is greater than or equal to 0 part on the top, and the x is less than 0 part on the bottom. Does it make any difference?
No.
No, it made it. Okay, so what about this one? Little tougher. Now, where's our breaking point this time? Negative 1, all right? So when we write our function down then, we're going to have a part that is, what about the right part? What's the domain of the right piece going to be? Greater than negative 1, but not equal to, right? Because I have an open circle there. So x is greater than negative 1, and the left part? Good, okay, less than or equal to negative 1. Good. So let's do the right one first. This one is maybe a little bit easier because, well, sort of. I mean, we can, I guess, see the y-intercept, but it doesn't fall in a nice, convenient place, does it? I mean, we can maybe see that it's negative 1/2, but what if it didn't fall in a place where it was so easy to see like that? We don't have to see the y-intercept directly. As we learned in, what was it, 2-3, one of those two sections, 2-3 or 2-4, we did stuff like this, where if we're looking at a graph, we determine what's the line going to be, right? Let's start off with the slope of this guy. What's the slope? If I pick a point there that's convenient, right, and make a slope triangle, and then the ant moves to the right until he finds another convenient point where we're crossing at a corner of the graph paper, I can make my slope triangle. What's the rise between those 2 points?
Negative one.
Negative 1. Okay, what about the run?
2.
Plus 2, so negative 1/2. Good, so we got a slope on this side of negative 1/2. Now, the y-intercept, I mean, maybe we can see here that it's negative 1/2, but pretend that we can't. How could we find the y-intercept? If we don't know what it is, if we can't see it on the graph precisely or directly, what if it was some weird decimal or some weird fraction? What was our trick? What do I do to my starting point, I guess, is y equals mx plus b. If I want to find out what b is, what do I have to do to the rest of the equation? Good. Plug in x and a y, and we just found m, right? So we could pick an x and a y value. Well, here's one that we used right here. What are the coordinates of that point? 1, negative 1. Okay, good. So if I plug negative 1 in for y, 1 in for x, and negative 1/2 in for m, let's see what we get. So negative 1 equals negative 1/2 is my slope times 1 plus b. So that gives me negative 1/2 times 1 is just negative 1/2, right? So negative 1 equals negative 1/2 plus b. What do I have to do to get that b by itself to solve for b? Add 1/2. And what's negative 1 plus 1/2? Negative 1/2. So I got b, I got m, right? And so I know then that for the right portion of this, the right piece, my equation is y equals negative 1/2 x minus 1/2, right? Okay. All I need to do is find m and b to find the equation of the line. Now what about this guy over here? So what's the slope this time? It looks like it's 1, doesn't it? It's rising by 1 and running by 1. So on this side, I know m equals 1. Now we could do the same process, but we could even take a little shortcut here, couldn't we? We could look at the trend of this line. If I were to continue this thing, if the slope is 1, then to get to the y-axis, I'm just going to continue that trend. I'm going to rise by 1 and run by 1. And that's where it would go through the y-axis, isn't it? Right? So even though it doesn't, that's the y-axis of this line. We're only graphing a portion of it. It does, I guess I shouldn't say it doesn't. Even though we don't graph the line there, if the line were to be graphed forever, it would go through the y-axis at 2. So we could use this other technique if we wanted to, sure. But we can. This is a pretty easy one where we can just see that that line would have gone through that point right there. So we know b equals 2, right? And so what's my equation? Yeah, y equals x. So 1x, we write as x, plus 2. That's it. Okay? Make sense? All right, I think that's it. Yep, that's it. Okay, I don't want to do this now. Okay, let's sit down. You can work on this stuff.